All right, today we're going to be learning how to prove triangles similar. So if you remember the beginning of the year, we talked about how to prove triangles congruent when we did all those triangle proofs. And there are 5 ways to name triangles congruent. We had side, 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 angle, 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 side, and HL. So there are 5 different ways that when looking at the picture, we can mark up and figure out that they were congruent. Now, similar triangles, we talked about that similar shapes aren't the same size. They have ratios for their sides. There are 3 ways to prove triangles are similar. The 3 ways are angle, angle, side, 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 and side, angle, side. To do these, whenever you have a side, so for the side, side, and the side, angle, side, you have to make sure the ratios are the same. All right, and for the angles, they have to be the exact same measurement. So what we're going to do is we're going to practice figuring out if the triangles are similar, and if so, we're going to be writing those similarity statements. Now remember, a similarity statement looks like this. When you have triangle something is congruent to triangle something. And we're going to also state what theorem justifies it and why. So here's our first one. We figure out what we have here. So to me, all of these are sides. That's a side, that's a side, that's a side. So we're going to be guessing it's side, side, side here, but we have to prove it. And here's how we prove it. We're going to create the ratios. So I'm going to start with the smallest side and kind of work my way up. The smallest side over here is AC, so that's 6. Over, the smallest side on my other triangle is 9. I'm going to reduce the fractions if I can. 6 over 9 reduces to 2/3. All right, I'm going to look at the next smallest side, which is 8. All right, 8 is similar to this 12 over here. If I reduce that, I get 2/3. So far, so good, but you have to check all of your sides. So we're check the last one, the biggest side. We've got 10 and we've got 15. So 10 divided by 15, which reduces to 2/3. So I would say, yes, these are similar because they all have the exact same ratio. So I would say yes by side, 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 and I would name it triangle A, B, C is similar to triangle, naming it the same order. So if I went A to B to C, I'm going to name it D, E, F. And that would be my final solution right there. Okay, but you do have to go through each side. You can't just stop after 2 and be like, close enough. All right, you gotta try all of the sides. All right, so for this next one, let's look at what we could potentially have here. So we've got a side there for MN. We've got an angle here, and we've got a side. So we're thinking it's side, angle, side. But again, we have to check those sides to make sure they're the same ratios. So we start with the smallest side here first. We've got 3, and we're going to compare that to 4. So we've got 3/4. All right, and that ratio did not have to be changed at all. Our other side here is 6 and 8. So 6 divided by 8. That reduces to 3/4. So they are the same ratio, which means, yes, they are similar. So we can write our similarity statement. Triangle MNP is similar to triangle. If I named it MNP, this one has to be named QRS. And there's that answer. Try the next one on your own. See how you do. When you've done it, unpause the video, and we'll go over the answer together. So for this one here, we gotta figure out which of our reasons we think it might be. So I'm looking at this, and I've got a side, I've got an angle, and I've got a side. So I'm thinking this might be side, angle, side. I gotta check my sides though. So I'm gonna start off with my smallest side here. That's 20. Over, the smallest side over here is 18. All right, 20 over 18 reduces to 10 over 9. We're going to check my other one. My other side is 36 and 24. 36 over 24 reduces to 6 over 4. All right, which actually reduced to 3/2. So right here, our ratios do not match. So this is no, they are not similar. All right, find this last one. Well, this one we have no sides or even angles marked up. So they don't give us some information, but they give us this. That those two lines are parallel. And if those parallels, we can talk about corresponding angles. We can say angle R and angle S should be the same because of corresponding angles. And this angle U and angle L should be the same. And right there, we've got our angle and we've got our angle, and that's enough. So I would say this is yes, angle, angle. And I would say triangle, R-U-T, is similar to. So if I name it R-U-T, I'd have to name it S-L-T. And that'd be perfect. So that's how we name them. So now we're going to use similar triangles to kind of create our ratios and keep solving for problems. So here we tell them that, or they tell us that these two triangles are similar, and we have to find the values of x and y. So it doesn't really matter which one we solve for. Okay, let's solve for x first. So x is right here. That means that this side is going to be similar to this side over here. So I'm going to have 18 radical 3 over x equals, then you want to pick two more sides. Let's avoid that y there. So I think the two sides I want to pick here are 18 and 9. So 18 over 9. What we're doing is we're going to cross multiply here. So I'm going to do 18 radical 3 times 9 equals 18x. So I do 18 times x. 18 times 9 here. 18 times 9 would get me 162 radical 3 equals 18x. Divide both sides by 18, and I get 9 radical 3 equals x. So there's x, we're good to go. All right, for y is right here. So y is similar to that 18. So I'd say y over 18 equals, I'm going to use this 18 and this 9 again. So 18 over 9. I'm going to cross multiply. I get 9y equals 18 times 18, which is 324. Divide both sides by 9, and I get 36. We're good to go. All right, this next one says a person 6 foot tall casts a 1.5 foot long shadow. At the same time, a flagpole casts a 7 foot long shadow. How tall is the flagpole? So this is technically our person here. All right, that's our little person. They are 6 feet tall. And remember, your shadow, it goes on the ground. So this is their shadow here. Okay, and we have our flagpole, and it's casting a shadow as well. They want to know how tall is the flagpole, so that's our x. We have to create our ratios. Do this. Whoops. So I'm going to say 1.5 compared to 7, so 1.5 over 7 equals 6 over x. And we're going to cross multiply. 1.5 times x is 1.5x. 6 times 7 is 42. Divide both sides by 1.5, and I get x is 28 feet. So your flagpole is 28 feet tall. For this one, these two triangles are going to be similar. All right, reason being they've got these little parallel lines here, which means I'm going to have alternate interior angles. I've got this angle and this angle being the same, and I've got my vertical angles being the same. So we have to kind of compare them. So if I'm looking at this, I'm going to say 16 is similar to that 4, so 16 over 4 equals x plus 18 over x minus 3. Now we're going to cross multiply. So I've got 16 times x minus 3 equals 4 times x plus 18. I'm going to distribute, so 16 times x is 16x. 16 times negative 3 is negative 48. 4 times x is 4x. 4 times 18 is 72. I'm going to subtract that 4x over, and I'm going to add the 48 over. Divide both sides by 12, and I get x is 10. Now, that's not the final answer, though, because they want us to find JL. So JL is this side right here, so we're going to plug that back in. So JL is going to equal that x value, which is said was 10, plus 18. So JL equals 28. And that'll be my final answer. So please make sure you're double checking what they want. All right, now we've got this picture here. So if you notice, all these other ones have two separate triangles. And I want you to get in the habit, we're going to redraw these. All right, so we're going to redraw this little baby triangle here. Of V, U, T. And the big old triangle of S, R, T. Just so we can visualize it better. So on this VUT triangle right here, we know that this side right here, VU is x, or 6, and VT is x plus 2. For my big triangle, we know this side is 14, but this side is these two lengths combined, this 3x minus 3 and the x plus 2. So I really have here 4x minus 1 as that side. Once we have that, we're going to make our ratio. So I'm going to say 6 over 14 equals x plus 2 over 4x minus 1. And we're going to cross multiply. So I've got 6 times 4x minus 1 equals 14 times x plus 2. And we're going to distribute. 6 times 4x is 24x. 6 times negative 1 is negative 6. 14 times x is 14x. And 14 times 2 is 28. I'm going to subtract that 14x over and get 10x. I'm going to add that 6 over and get 34. Divide by 10 and I get x is 3.4. Now we need to double check and see what the question's asking. They want us to find VT. Now remember, VT is right here. It's that x plus 2. So I'm going to plug in my x value and add 2. So VT is my x, 3.4 plus 2